All right, welcome to basketball. Wait, it's not basketball practice. It's math practice with Mr. Douglas. Yes, today we are going to be looking at proportional relationships and parallel and perpendicular lines. Does it get any better than that? I don't think so. Let's get right to it, shall we? Here we go. So today we are looking at proportional relationships. And this goes together with graphing, and you've probably heard of this equation, and we've been using this quite a bit. If you've been following along, y equals mx plus b. So it's important for us just to make sure that we know what we're all talking about. B is, of course, the y-intercept, which just means where does the line cross the y-axis. M is the slope. And then you have x and y. Now, these are basically your inputs and outputs, basically. So these kind of go together like that. So what is proportional relationships? So proportional or direct relationships. And you're going to see this kind of written different ways, but I'm going to say it's just y equals mx. That's it. There's no plus b. So that means for it to all be proportional, the line has to go through the origin. Okay, so that's one thing to kind of keep in mind. You're going to find different websites and textbooks also. Maybe say something like y equals kx. And you're like, kx? I'm so confused. Where did k come from? K will stand for constant, and that's your rate or slope. And these are all kind of using different words that all kind of mean the same thing. So if you see that, don't freak out. Just think of a linear equation with the line going through the origin. And then we're talking about things that are proportional. It basically means the line increases at the constant rate. So let's just take a look at what that might look like. So here we go. Here's our, your average kind of graph. That's kind of written. And let's just say you had a line that was kind of going like this. And imagine it was straight. So imagine your teacher could actually draw a straight line. That would be crazy. It's not one of the prerequisites to being a math teacher, but it probably should be. So, is this a proportional relationship? So basically, you're asking yourself, is it straight? Yes. And does it pass through the origin? So does it go through 0, 0? Yes. So as long as you get two big giant check marks, yay, it's going to be a direct relationship, a proportional relationships. So again, if I went and said, please go and graph like y equals, someone say y equals, I was thinking something else in my head, 5/3 x. So again, there is no b. Now this sometimes freaks out kids. That just means you start right here, right in the middle. And remember, this is rise, and this is run. So it's going to rise 5, 1, 2, 3, 4, 5, and it's going to run over 3. So it goes up 5, goes over 3, and there's my other dot. Woohoo! And there we go. Okay. So that's kind of what it is. Not too bad. Pretty basic. And if you see something that, maybe it's important to show you what is it not? So what does it not look like? And sometimes this gets kids. So, if your line was going like that, is that proportional? We're like, well, it's straight, Mr. Douglas, it's straight. Yes, but does it go through the origin? No. So it's not. So why is it not? Well, to be having the kind of consistent rate and that sort of thing. And I'm just putting colored dots here just for fun, really. At time 0, so at 0 on the x-axis, it's already up here, isn't it? And then at time 1 and time 2, this does go up at a constant rate. It does go up at a constant rate. But at time 0, it's already here. So we can't say it's a proportional relationship because at time 0, it's already got a head start. It's like having money in your savings account. If your parents were awesome when you were first born and they gave you $10, and then every year after, you save $20. Well, it's almost a proportional relationship, and of course, you know, that would be like y equals 20x plus 10. If you're kind of like, oh, hey, that's a pretty cool question. That kind of stuff. So that is what we're going to be looking at. In the next section, we are going to be looking at parallel and perpendicular lines, which is not challenge. Not really. We'll be taking a look at some challengey ones, but it is standard. So stick around for the next part. Okay, in this section, we're going to be taking a look at parallel and perpendicular lines. We'll start off with some standard level stuff and then jack it up to some challenge level material as well. All right, let's get to it. Parallel and perpendicular lines. Yes, we have come to a lesson that I really like, and most kids seem to like it a lot. We're talking about straight lines here, and we're going to have two different types of lines. The first one is going to be parallel, and the other one is going to be perpendicular. So I'll show you what it looks like and tell you what you need to know. So parallel line, so here's just our giant graph. And here is our major line. So this is the line that we'll be talking about. Now, a parallel line has the same slope. Okay. So if I was going to draw another line just like this, it has to be parallel, so it's going to have the exact same slope, the same m, so it would be something like that. They never cross. So they never cross, right? They go on forever, but they probably have different b's, different y-intercepts, okay? Now, perpendicular lines, so perpendicular lines are lines that cross at 90 degrees. So there we go. Nice little 90-degree sign like that. And these do cross. So they cross at 90 degrees. And you can kind of see that there. And they have a different type of slope. They have something called a negative, so get it? Negative reciprocal. So it's a negative reciprocal. Now, that seems really complicated when I say it. Let's take a look actually what it looks like. Okay, so here we go. Here's our equation. Y equals, and I'm going to use a fraction, 3/4 x plus 2. And if you wanted something that is parallel, let's think of any line that could be parallel. So all we have to know is that it has to have the exact same slope. So a parallel one would be like y equals the same slope, 3/4 x, but maybe it's -7. Okay, that's parallel. But if we wanted to go perpendicular, it has to be a negative reciprocal. Okay, let's put it into kids' terms, shall we? You need to flip this, so you need to flip it and change the sign. Okay, so that means I'm going to flip it 4/3, and I'm going to change the sign. Boom, negative. Ooh, cool. And maybe, I don't know, -3. Sure. The b can be anything. It doesn't matter. The big thing is I flip this and I change the sign. That's it. Parallel lines, perpendicular lines. Okay. So now that you have an idea of what it is, what do questions look like? That's what you really want to know. So here's the question. Write an equation, and these are what you're going to see, right? There's going to be some different versions of these. Write an equation, and depending on what your teacher's asking, write an equation parallel to y equals, I'll just go 6x plus 2. And then they're always going to give you something that the line passes through. So that passes through, and then they're going to give you an ordered pair. So it passes through, I don't know, let's say it passes through 3, 4. That looks weird when it's, let's close it up. So I put 3, 4 in orange. So there we go. Okay, so a couple things. What do you really need to do? What do you need to do? You need to, step 1, replace x and y. So you need to replace x and y And you then need to go and, all right, I'll write this down. You're going to keep the m because it's parallel. And then you're going to solve for b. That's what you're going to be doing. So let's go and do that. I'm going to put the 4 where the y is. So I'm going to put 4 is equal to, and now this is parallel, so it's going to keep the same slope. So 6, I'm going to replace the x with 3, and I don't know what b is, so I'm going to go like this. Boom. That's all I'm doing. So 4 equals 18 plus b. So it's some basic math, right? I'm going to subtract 18, and b would equal negative 14. So that's my new b. So what is my actual equation? So my actual equation, dun 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 dun, is going to go here. It would be y equals still 6x, because we're talking about parallel lines, but my b is going to be minus 14. Okay, so that would be the equation parallel to that goes through 3, 4. Let's see another one. Now, you got it. I'm going to show you a perpendicular one. And it always starts out the same thing. So write an equation, perpendicular. So apparently green is the color of perpendicularness. Perpendicular to, and I'm going to make this just negative 5x minus 1. Okay. That passes through. Oh, what point should we pass through? Let's pass through 3, negative 4 this time. Ooh, crazy. Okay. Same kind of steps, but let's just, excuse me, let's just take a look at, if my slope is negative 5, and I'm going to do this just a little bit slow, which is really negative 5 over 1, isn't it? And if I want to make it perpendicular, I need to flip it. So I put it over 1 just to make this look a little bit easier. I'm going to flip it 1 over 5 and change the sign. So it's going to go from negative to positive. So this is my new m. Okay, so if I'm going to do something perpendicular, that's my new m. I'm going to go and replace y and x. Still, I'm going to go and replace the y and the x. So that's going to be my y. Whoop. And this is going to be my x. So this is, I like that color. So let's go and do that. So I got negative 4 is equal to my new slope, which is 1/5. And I'm going to times it by x, which is 3. I'm going to subtract 1. Now, I don't know about you, but 1/3 times a 3, that's going to be obviously 3/5. So I'm going to get negative 4 is, oh, sorry. Oh my gosh, what was I doing there, Mr. Douglas? Oh my gosh, this has to be plus b, right? That has to be plus b. Of course it does, because we don't know what b is. We're solving for it. Silly teacher. Okay, so this is going to give me 3/5 plus b. Okay, let's go and subtract 3/5 from both sides. Subtract 3/5. So b would equal, and hopefully you're like me right now, and I'm using my calculator. I'm going negative 4, and then I'm going to go minus 3/5 on my calculator. I get negative 23/5. That's exciting. Negative 23/5. Great. So what is my new equation going to be? Dun 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 dun. The perpendicular equation would be y equals your m, which is going to be the difference, right? It's going to be 1/5 now, x, and then you have a brand new b, minus 23/5. And there you go. So parallel lines and perpendicular lines. Okay, thank you sports fans, math fans. Hope you learned a little bit about parallel and perpendicular lines, as well as lines that are proportional. Until next time, have a great day.